Okay, good afternoon. We will start just in time. Okay, we have three panelists just on my side, two of them for the present time. Sébastien Maire, is Paris Chief Resident Officer. He will explain better about what he is doing. Unfortunately, Andras Solti Nagy had to cancel its participation because there is a very important meeting today in Brasilia for the preparation of the next World Water Forum next year in Brasilia. So he had to give up. He deeply regrets that. And just on my side, there is Arjan van Timmeren, who is the head of the Amsterdam Institute for Advanced Metropolitan Solutions. Myself, I'm Daniel Scherzer from École des Ponts, Paris Tech. Other convener is Chedu, who is late, of course. And just on my side, Stefano Tinti from the University of Bologna. Herman Ruschenberg from TU Delft has also had to cancel at the last minute. But okay, the last person who is missing for the present time is Hervé Le Treut, who will arrive in rush, simply due to the fact that his airplane has some trouble. They had to change one wheel before they left from Paris. So we hope they did it correctly and we will be able to land safely and arrive in rush in 20 minutes, something like that. Okay. Okay, the general topic of this session is about the problem of interaction between urban and geophysical systems. It's becoming a more and more important question about climate change and as well about urbanization. Here there are some figures well known, estimates, okay, about the fact that the population now is highly concentrated in cities. These cities are also producing a lot of greenhouse gas emission, about 60%, consuming a lot of energy, 80%. And of course, there are a lot of infrastructure facilities, assets in these cities. At the same time, there are other interactions which are quite important and which are not new in a given way. Most of the cities are under threat of important geophysical events. At the same time, we have to admit that the way cities are built is not really optimal, and they provide only basic services when they do it, and the quality of life inside of them is not so good. So there are different organizations which are taking care of that. So we will proceed by following three themes which are more or less obvious. What about the past? What about the present? And more difficult, of course, what about the future? We will first have this kind of panel discussion, and at the end, there will be a general discussion. You can take the floor and so on. Meanwhile, during the presentation, you can use also Twitter. There is an address given there. And to make known what are your questions and are you satisfied by the presentation or not? I hope so. So we are starting with the past. The past is indeed, we are inheriting a lot of concepts which are no longer so much appropriate. And therefore there is a series of questions. And I believe Sébastien Maire is willing to be the first speaker about that.
Thank you very much. Good afternoon. Thank you very much for inviting me to participate to this conference. I'm not a researcher. I'm a practitioner, so I'm going to speak as a practitioner. So forgive me if my speech is not as scientific as you would like, but I'll do my best to give a practitioner point of view on these fascinating issues. So I'm the Chief Resilience Officer for the city of Paris. Thanks to a program, a worldwide program launched by the Rockefeller Foundation for its centennial anniversary in 2013. And this program involves 100 cities over the world with a very attractive system. The Rockefeller Foundation, for instance, is reimbursing my own salary to the city of Paris for 2 years, and they do that in 100 cities. They provide us support with a strategical partner, economical partners, and more than all, I benefit from a network of 99 counterparts everywhere in the world, small cities, big cities, almost all continents. And the benchmark approach of this network is really relevant. They really provide tools and credits to work together, and it's very efficient. So I'm the Chief Resilience Officer. What is this weird position? It's quite a new position in the civil society or in the city governments. I'm supposed to be the cross-cutting person within the city administration. Like all public administrations, you know that our departments work in silos, and it's not often easy to build the next generation of cities, to innovate, working still with this silos approach. So this whole program was built in order to cross-cut the silos and to build integrated, holistic, and cross-cutting strategies to reinforce the resilience of the cities. So what have we been talking about? Of course, I guess here everyone has an idea about what is urban resilience. I advocate to say that it's not a new fashion. After the smart cities, the sustainable cities, the climate cities, we often hear now about resilient cities, but resilience exists since cities exist, and a city that is not resilient disappears. So we can be more or less resilient. And after the 20th century, where globally the Western society was persuaded that techniques and technology would always be stronger than nature, at this beginning of the 21st century, we realize that maybe we need resilience in order to build the future. So we're talking about the capacity of individuals, communities, institutions, businesses, and systems within a city to survive, adapt, and grow, no matter what kinds of chronic stresses and acute shocks they experience. So what are we talking about? You have here a list of potential shocks that cities can face. Most of them are geophysical, or a huge part of them are coming from the nature. And the specificity of this approach is to work both on the shocks and on what we call stresses. Water scarcity, for instance, air pollution. But the difference between both is disputable, because, for instance, we consider now that a heat wave is a shock, but we perfectly know that tomorrow it will become a stress. So it depends on the context, it depends on the time in the century. What is interesting is the fact that with this approach, we consider that we can learn from shocks. And of course, if a city is resilient, it has to not to get back at the initial status, but to a stronger one in order to be able to face the same kind of shock in a better manner. So, talking about the past for the topic of this first part of the debate, I just want to illustrate this chapter with one of the main risks that Paris faces, and which is what we call a centennial flood, but let's say a major flood that occurred in 1910 for the last time. And we know now, thanks to the OECD that released a study, a really precise study a couple of years ago, that it will cost around 100 billion euros, that will have more than 400,000 jobs destroyed, that if the subway, for instance, if the water gets into the subway, we'll need 5 to 10 years to rebuild the whole network, and the GDP of the whole country will be affected for more than 5 years. So it's a huge issue, and during the 20th century, it was not considered as a huge issue, because at this time, engineers were totally persuaded that we would find technical solution in order to protect the city against this major risk. But 1 century later, we didn't. And actually, we did worse, because 1 century ago, we hadn't built yet all these critical systems that are now running the city: transportation system, energy systems, water, sewage. And all these systems were built without considering the risk of flood. And the main illustration of this is electricity. The city built its electricity substation underground, close to the river. And of course, we know now that it will occur a huge vulnerability, much more than water, actually. This is, for instance, it's in French, but it's just to have a global view. A map that was built by a PhD student a couple of years ago, because all these critical system operators met for the first time to work together, especially about the domino effect among them. 5 years ago, for the first time, they decided, thanks to the city, to meet and to share experiences, data, in order to fight together against this risk. And you have here a map of the weaknesses of the city in case of this major flood. In blue, you have the water flooding, and in yellow, the electricity collapsing. And it's especially because we didn't take into account the geophysical aspects during these 20th centuries, that we are so much vulnerable now, and that it will cost so much after this event that it's sure will occur someday. I stop for the moment.
Okay, sorry. Okay, Ariane will go on this topic of past misconception, etc.
Of course, yeah. But I will also always thank you for the opportunity, first of all, to be with you here. I will also immediately relate it to today's work, because that's our let's say, our habitat at the moment, right? My background is, I will not tell too much about it, but I'm actually from the Delft University of Technology. I'm a full professor there at the University of the Faculty of Building Technology, Building and Built Environment. But besides of that, I'm the scientific director of AMS Institute. This is a new institute, 2 years ago, started by MIT, TU Delft and Wageningen University. So it's a joint collaboration between 3 universities, together with a lot of industries like Waternet, IBM, Cisco Systems, Alliander, big companies, Shell, you name it. So we try to really address a quadruple helix. So we include citizen platforms, and we include public and private and academia. And we try to really, let's say, speed up science for society. I must say sorry for the fact that my slides, there seems to be a slight technical problem, that it's a bit extracted. So they're more horizontal than they should be. So it looks even more oppressive if you look at Shanghai in this picture, but it's a bit more dense here. So my first statement, of course, is that we are, as Kuhn, known from Scientific Revolutions, would have said, we are in a paradigm, and we need a paradigm shift. So there is really what you could say, a lock-in in infrastructures, in the planning of cities. And we continue at full pace. We should, of course, because of the numbers were shown before, but actually we are locked in this issue. So what we aim to do is we try to explore opportunities available through new technology, IT, geosensing, sensing, but all real time the most. And I think that's where we can address two resilience challenges, like stated just before by, for example, for the city of Paris. But we do so with Amsterdam as a living laboratory in the Netherlands, but also we are in close collaboration with Paris, for instance, but also with many other cities around the world, like Boston, Buenos Aires, Sao Paulo, Singapore, and Sydney. And this group is growing as well. So what we try to do is, based on this sensing and based on the idea of looking at a city from another angle, trying to really address the dynamics of a city. Because so far we always have been modeling cities, trying to prospect its use. And of course this is always near the reality. And the opportunities of new time sensing and another way of perspective looking at cities, of course, that you can really address to change. Either be a change through climate change, climate effects, or be a change through use. And I think I will put a bit of emphasis on this aspect of use. We address to it as the urban metabolism. It's a metaphor. You should read it as an analogy, of course, because it's not as easy as a metabolism of a plant or an animal cell, because in a city there are humans, and humans actually are malleable, and that means that they are not acting as they should act. So they respond to change, climate change, or change in regarding to resilience, disruptive events, and actually we should take care of that. So that was the first point, and I will come to that a bit later again. Another thing is, I think we should not forget about what we are here for, which is prosperity in the end, I would say. And if you look at the City Prosperity Index by UN Habitat, it was introduced in 2012, and there's one new and important element, which is infrastructure. This is a kind of, you might say strange, but it's new at least, because the others are all related to the triple P, people, planet, profit, from before. And this is the first time that they actually say, for prosperity, you need to be interconnected with the surrounding hinterlands of the city, but also with other cities. Keep this in mind, because this is also related to IT connections. Because if we look back to Eugene Odum, the famous ecologist, he had this simple scheme of our environment, which is a vertically aligned, let's say, four-layered environment of abiotical, biotical, physical, and in between the technical layer, which is us, which is the buildings, infrastructures. And that's where we actually make our most of our changes in the environment. But lately, you might say, and this is Benjamin Bratton's scheme, and he calls it the stack, you have a lot of new layers in this technical layer. And these are the IT-related layers. And the interesting thing about this is that they are not anymore, by definition, vertically aligned. This means that you can have let's say, you can form a community based on energy or on water together with other people who are not living next to you. And you might say, what is this of use for our today's, of this conference's focus? Well, this is very interesting to know, because these people together, they can also form agents of change together much faster than when they just have to be physically aligned. And I will show one example in 2 slides from here. It has relations to this Internet of Everything and to our possibility that we really are actually able to change, let's say, to measure real time. I just put here some examples from mobility. We also do a lot of mobility-related research. This is from London, and so you can have the real-time use of bikes, but also related to other issues. But my most important statement to come to the example of also flooding in a while is that you should first start with the people and use the communities of these people to do so. And you can do that both on a very, let's say, social based, as we are used to, in participatory or inclusive approaches, but you can also do it on a very, let's say, double way based on technology as well. And that's what we try to do as well. So I will explain it, I try to explain it very easy. But the idea is that we so far were able to, of course, to make the step as a society, as scientists, toward big data. But we are now making this step to this next step, and this is called human computation or human-enhanced computing. So what does it mean? What we try to do actually is we try to really use all of us to really measure, for instance, for climate-related data or measure change. And we do so as is shown here. This is a social glass project in Amsterdam, in which we do not only sensor-based analysis or environmental analysis, but also social media, because people can also respond to let's say, changes in rainfall in a positive or a negative way, because the value to data is, of course, different for each of us. I will go through this a bit faster because I would like to show you just one example and then you will understand a bit better, I suppose. This is the project RainSense in Amsterdam. It's a joint process, a project with 7 partners, the universities, TU Delft Wageningen and Meteorological Institute, Waternet, IBM and AMS. And the idea is, of course, that we have every now and then, as you know, these peak rainfall events. And this is just one example in Amsterdam, and it happens 3 times a year, or sometimes a bit less. But the idea is, of course, that if you look, for instance, at social media, this was at that event in Amsterdam, you see that there's a peak in Twitter. It was actually in the top 3 of the Netherlands. And it was actually a peak rainfall event, which is very local, because when we measured, it was only in one neighborhood of Amsterdam. And, well, the importance why I say this is because a lot of prognosis, of course, and preparations by urban professionals have been made based on this kind of prognosis, but you would like to really respond real time to where the problem is. So this problem, actually, what we did is, together with the mobile company and Meteorological Institute, we could, based on the use of people phoning and using Twitter, as they were complaining or they were shouting or they were tweeting, we could actually very precisely predict the exact position of these rainfall events. And this goes further than, let's say, on a city or a district scale, but it's actually on let's say, on the accuracy level of one street. And this is very valuable, you might imagine, because in that moment we could actually really, the urban professionals could be attached to such, let's say, street secured prognosis of this rainfall event. But also we could develop, which we already did, a weather app which actually makes it possible. For the Netherlands, it's very important that we can bike, so that people can know, if I take that route, I will be dry. If I take the other route, I might get wet by rainfall, because it's that local. We all know that, of course. So this is just one example. I will show a bit more examples later, but just to give an idea that I think this human-enhanced computing will be one of our new ways of, in addition to existing, let's say, science methods, to change our field. Thank you.
Thank you. I suppose Sébastien is ready to, because in fact you already spoke about the present state. So Sébastien has to speak about that too.
Yeah, I want to speak about the present, trying to illustrate what you just said about urban metabolism and the way the cities now are trying to face with this new approach. As I said before, cities are working within silos. And as we all identified a long time ago, that was not the most relevant and efficient way of governance. It's the same in the private organization, actually, but we decided to work with this project mode, for instance, in order to build climate plans involving people from all the different departments, stakeholders, private stakeholders, academia, people, real people, I mean citizens, in order to build in a cross-cutting way some things that can take into account this holistic approach of the urban metabolism. But we did that for climate plan, and as it worked, we did it for many other topics. Smart city, all the cities now are building smart city processes and strategies. Inclusive cities, we're also working more and more about circular economy, urban farming, all these kind of cross-cutting approaches, but there are so many that this is, for instance, all the current cross-cutting teams in progress now within the city of Paris. It's in French, so it's just to give a global idea, but we have something about noise, about air pollution, about social action for elderly people, and so on. So when I was appointed, my first question was, this is really interesting because all of them are cross-cutting processes, but what is the transversality between them? Because all these people are working sometimes on the same topics, but they don't share. And it's a waste of efficiency because we have many people working, spending hours with stakeholders in order to work one day about climate, one day about smart city, one day about inclusive city. And for instance, many stakeholders, especially from the academia, often tells me, we're getting tired to be involved in your processes because we have to have one person full-time just to participate to Paris workshops, and it's getting really harassing to be that much concerted on your processes. So the resilience approach proposes to reconnect all these processes in a governance way in order to be more efficient and to create solutions that take into account this urban metabolism. And it's important, so for instance, this is one of the tools we use. I guess you won't be able to read anything, it's really small, but this is one of the tools we use to materialize this holistic approach. Once we have a project, a policy, we put this policy within this tool and we try to light all the different parts of the territorial development to see if we didn't forget something. Because, for instance, the climate plan can also serve inclusive goals. We can use smart city to better do for the climate and so on. And more than all, it could prevent ourselves to do mistakes. And I will just give you a couple of examples. We're talking about interdependencies on a territory. And I will take as an example the climate goal, which is the most important, and that's totally normal. Now it's even in the public sector in France, it's the priority. And all the policies try to address this huge challenge of mitigation and adaptation to climate change. And for instance, in Paris and in other cities in France, we develop many programs to reinforce to green the city, to plant everywhere. We encourage citizens to grow vegetables on their balconies, to grow vegetables in the street. We take off the material of the pedestrian ways in order to plant. We want green everywhere. And in the same time, we want water everywhere, because we know that it has a real effect on heat island effect. It can really decrease the temperature of the city during heat waves. So we're going to spend tens of millions to adapt our public spaces in order to have water everywhere in the city. But this was the reflection within the climate plan process. And if I go to see my colleagues who work on the health and sanitary process, and if I ask them, what is the main risk in the coming decades? They are unanimous: mosquito. And if in Paris, in 10 years, we have a mosquito with a lethal disease, we won't care to be hot during heat waves. And growing vegetables and greening the city everywhere and putting water everywhere in the city helps mosquitoes to reproduce themselves. So the resilience approach doesn't say that we shouldn't green the city or put water everywhere. It just says, let's take it into account from the beginning. And for instance, we can put water everywhere in the city. We just have not to have, we just need to have moving water. And if the water is moving, we can find technical ways to have everywhere moving water. And then mosquito is not a problem with water. The same for the greening of the city. As we are encouraging now and training our citizens to become farmers or to grow on their balcony, in the same time, we should train them to have the best behavior in order to prevent mosquitoes, as it was done in Cuba, for instance, or in southern countries that could eradicate malaria thanks to behavioral changes. So it's the same. This is in French about, for the French people, the eco-district Vauban in Germany, Switzerland, Freiburg. It was one of the first one. It was, when it was created, it was a model, a real model for sustainable architecture, taking into account the climate issues and the environmental issues, water issues, and so on. But now, 20 years later, there are much more publication about the fact that it forgot something, the social part. And so mainly now, the background on this project is negative, more than positive, because it didn't address all the main challenges, but only part of them. It's the same, just to end this, just two more examples. This is a communication campaign in France in the 90s from the national, to translate ADEME, the National Agency for Energy and to Save Energy. It's a public administration, and at this time, the state was encouraging all the people to have fireplaces in their home, because it was considered at this time that the carbon captation of burning wood in fireplaces was very efficient, and actually it is about carbon, but it's not at all about air pollution. And now air pollution kills much more than heat waves. And so now we are doing exactly the opposite. And with public campaign saying to the whole people, please don't burn too much wood in your fireplaces because it creates a lot of air pollution. But this was an official public campaign 15 or 20 years ago. And the last example is still about air pollution and greening the city. We think that it's great to plant trees everywhere in our cities. We prefer to walk and to live in cities with trees. And we think it's much better for the environment. And it is, especially for heat waves or many other issues. But it's not at all for air pollution, especially because of the physical aspect of the trees that keeps the pollution on the ground. Because the best way to fight against air pollution in cities is the wind. There is no other way so far to wind the city. And these trees, this is a research project led by one engineering school, Paris Engineering School, and they measured the fact that trees had a bad effect on air pollution. I'm stopping here.
I love to say something about the last part. Because it is indeed better to cut trees sometimes, but you actually dilute the problem, because the problem is not gone, it's just pushed away. So it's a kind of end-of-pipe thinking. So I'm not entirely agreeing on this point, but I understand.
We have to cut trees. I'm saying maybe we have to find other kind of trees or to separate them more. But of course, we still need trees.
Yeah. Now, I will address to this later in my slides, because I think what we need, and this really connects to what was been stated before, is what we need is, often it's claimed as we need a green-blue approach. I always say we need a hybrid approach. So we need a gray-green-blue, because the existing is still there and will be the largest share of all there is in cities, in their environment. So we need to deal with that. And you cannot just say, hey, we're going to change everything into green-blue. And so I would like to make a kind of a short statement about this. It's also about an integrated approach. It's about monetizing multiple benefits, ecosystem services, but also synchronicity of the stakeholders. This is actually a part of a project of GPI, Europe project, Green Blue Cities, but also I will show some slides of a climate kick project of Blue, Green, Green. The idea is, of course, that we should make a transition towards cities which react more, let's say, in a natural way to these heavy rainfall events, or at any, let's say, any kind of change related to perturbations of weather. And I think it should also be done at several scales, and they should be interrelated, from a city landscape up to building. And actually, if you look at it as let's say, the hydrological catchment areas, you can even define it into smaller and larger catchment areas as well. And we did some, I'm not going to too much explain on detail, but what we try to do is really related to this, also make a related strategy. Because there's everyday rainfall up to the extreme rainfall, which needs other ways of address. And for instance, making a green bioswale will take care of phase 2 and 3, but it will not for the extreme rainfall. So there's another category to say. And so it's actually this integrated approach which you were referring to, which is important to make it resilient, and also to really to address not only to rainfall, because one of the major problems also in the Netherlands, you might not know, is drought. Even there's this disbalances, which is the most shocking for a lot of users. So it's about this all integrated perspective that you should do, but you should also really relate that to, let's say, implementation. And so this is an example of Culemborg Langsmeer, in which I really try to show again this green-blue approach. If you look from it from the top, you can really see what is the difference. It's a green district, but what you don't know is that there's also a lot below the subsoil of systems of reclamation of black water, of grey water, of wastewater into nutrients and so forth. But the overall look also, it helps a lot to climate adaptation. And Vauban has been shown before as well, is another example of this. And there are issues related to social aspects. For instance, people are not allowed to have more than one car, but they park their car in the neighbor's district. So I can tell a lot more about that. But just to give a bit of an example, it has to be green-blue because the grey is existing. This is an example from China, the Bamai Canal, a canal which actually up to 5 years ago was an open sewerage, you could say. And what Joshua Todd did there, he just made a floating device made and together with, of course, an aerator upflow to include oxygen in the river. And actually, it's all nutrients. So it was not industrially polluted wastewater, it was residential wastewater, and it's almost all nutrients. So if you then plant these floating devices with plants, they clean, together with the aerator, they cleaned this canal significantly. Within 9 months, they were able to open it for the audience, for the public, and it became a park. So this is what I call this hybrid approach. It still is a hybrid canal, but you can really add to that green-blue approaches, which really address to the climate, which is really more extreme in its events. And the same holds for places like this square in Australia, and also, for instance, in Rotterdam we have the Bloemhofplein.
Example.
Okay, I'll give it to you later. It will be explained later. This is a nice example to show. And bioswales, of course. It's not necessarily really to change our street layout, but this is a bioswale which takes the first runoff of extreme rainfall as well. It just looks like an everyday green plot, but I can tell also a lot about it. But the idea is, of course, that this is only one side of the story, because this is the green-blue. But what you aim for is resilience, or let's say an improved urban heat island effect. This is a study which has been done in Amsterdam, which is called Amster Warm, because, well, we are not known as the warmest climate in Europe, but we have also warm summers sometimes. And so we have urban heat island effect experiences as well. And what we here did actually is to combine this green-blue approach with vegetation indexes, together with also the data sets of the vulnerable people. Where do elderly people live, or people who are ill, the young people, but also where are certain typologies of building, where are certain typologies of impaved, there's more topping, less green. And altogether you could actually then make a strategy, build a strategy for the city, which knows when there is a day of extreme hot temperatures, I need to go to this specific place, because a city cannot respond to all, it was just stated before, to all, let's say, urgencies, and they should really know precise where to go to. And this is actually this data collection combination. And this is where I would like to end my part.
Okay. Do you want to take up for the third one? I hope that Hervé will arrive. Okay. When?
Talking about the future, I want to start insisting on what Ariane said before, counting on the people and basing risk prevention policies on communities. This is going to be the backbone of Paris Resilience Strategy, which will concentrate much more on social resilience than on the infrastructural one. And it's because we have now many experiences and research program that was released and that show officially and the correlations that we felt, but that was not officially validated, that social cohesion is a key for resilience and to face the natural hazards our communities are going to face. This study is really interesting. It was released a couple of months ago, and researchers studied, they wondered why the differences were so important, the mortality, the number of deaths were so different from one village to another one in Japan with the same geophysical assets. It was the same urbanism, the same kind of houses. And during the 40 minutes between the earthquake and the wave and the tidal wave, some of the village could escape totally. 100% of the population was saved, where in other ones, 10% of the population died. And so it was weird, a really weird situation. And researchers found that in the villages with no death, social cohesion was very strong. There were habits of meetings, associations, conviviality organized within the city. And in other places with a large number of deaths, it was known that there were tension, social tension, and lack of social cohesion. So this is a key. Once the infrastructure fails, and for instance, we are working on the flood risk prevention in Paris within this community approach, especially, much more than do we have to build a better dike. You know, because we know that a dike has always its limits. Depends on the quantity of water. And so we are really committed in this soft part and this, how can we mobilize human sciences to face natural hazards? But in the same time, of course, the infrastructures are still important. And that's one of the main goals of the 100 Resilient Cities program, is to try to work on these infrastructure issues. Especially, it's not really the case in the Western world, but in most of the world it is. We consider then that half of the infrastructure cities will have by 2070 hasn't been built yet. So we can choose from now, if we build them the same way than in the 20th century, if we try to think about this infrastructure in order to, of course, give a service like a road or whatever, but in the same time, trying to address the two main issues in the world, which are climate change and inequity. And I'm going to give you just two examples about it. The one, the Bentham Plain Square in Rotterdam, because Dutch are really advanced on these issues. It's really interesting. It's in the Soho area in Rotterdam, which was known to face, let's say, social tensions. And there was a budget to rebuild the place, a public space. And then the resilience approach looked to this project, and it changed. At first, community was involved in the design. During a long-term process and not just a couple of meetings with a technician and a PowerPoint. It was a real involvement of the communities in order to design their direct environment, trying to reach their own goals, needs, and the result is really interesting, especially because instead of being a plain place, it became an amphitheater, which now serves, for instance, Christian math at weekends, open air religious ceremonies and recitals and hip-hop recitals during the week. But in the same time, in the basement, it's a multi-sport yard for football, basketball, and everything. In the same time, on the sides, it's designed in order to allow skateboarding. And as the main climate stress in Rotterdam, like in most of the Netherlands, is water and flooding, and especially rainwater management, because the sea level is really close, it's also a rainwater storage in the same time. And that is really interesting, because in France, for instance, for such a project, we would have had 5 boards, 5 different processes, one for the sport, one for the skate, one for the water, one for the community engagement, each with consulting firm, planning, stakeholders involvement, and so on and so on. So this integrated approach is efficient, actually. It's really efficient. And the other idea is that showing the water to the people and is in the same time really interesting as well, because we know that the culture of risk has to be increased everywhere. And this idea because in France, no one knows that we have this kind of storage tanker, because they are underground every time. And so they don't know that rainwater can be an issue. So showing it is also a way to be pedagogical, to train the citizens, and it's really interesting. And the last example is in Vejle, Denmark. Their main risk is that the fjord is going to grow, at the level of the fjord is going to increase, and they also faced a flooding risk. And they decided to build a dike. They had just to build a dike, but this dike became a social housing and public facilities dike, because it's not only a dike, but as they faced social cohesion problems, they needed social housing. They built building on the dike. And what is interesting as well, at first they are the nicest apartment of the city with a great view. Usually it's not for social housing, it's more for expensive real estate. But the whole project is designed to be part of the fjord. And so the people living in this building live with the water. And that's really interesting as well. And this is for the conclusion.
Also for my conclusion, because I would like to also discuss with people. Yeah, well, I think I can make it very short because this time. But I think Alfred Whitehead said this quote about civilization advances only by extending the number of important operations which we can perform without thinking about them. I partly agree with it, because it's of course we need to be able to do more with one square or with one event. But at the same time, the educational part is forgotten in this quote. But the most important thing which I would like to say is that this, if you remember the scheme I showed about from Benjamin Brereton, that networked environments perspective. So this people's perspective, which we can really use for measuring, and some of our PIs in AMS Institute also are now able also to measure with their mobiles, let's say between the signal, the signal antenna and the users, what is the distributions, what is the weather, and what is the what kind of rain events are passing in between. So you could really make a lot of improved ways of addressing based on this way of localized or distributed sensing, crowd sensing it's often called. At the same time, of course, we should really take care about this integrated focus. So this is just some flows from linear to circular systems from the Langsmeer districts I showed you before, the image, in which we're not entirely circular, but for wastewater, for carbon and for phosphorus to be reclaimed within a residential area. And so if you address to these kind of events, it really requests an integrated approach. Not only in this, let's say, in the organic and in the green-blue world, but also in the hard gray world, like in mobility. This is a project we did with Amsterdam and also the airport, in which we looked at inductive charging combined with photovoltaics and electrical mobility, combined with optimization according to grid topology. And it really is working towards the city of the future, in which we really can have a more distributed network, which really distribute, let's say, local generation of energy and storage in vehicles or in laptops or and we did a lot of studies on that, and it's really also implemented at the moment in several places. It really leads to projects in which this, let's say, almost abstract scheme of Benjamin Brereton becomes reality, because this is a bike road in the Netherlands, which is also a solar cell. So it takes and it makes energy, but it is also IT connected with users, and so in a way, this physical and the let's say the IT domains, they come together with the natural below. And this is not a very it's still with issues, but it works now well again. And but these kind of things are happening as we speak. And in this little animated drawing, there's another dimension which is happening actually. It's shown here in the left drawing and in the layers below. So you have the physical here in brown, the physical layer. I told to you about the IT layer, which is new lately, the last decades, which is the cyber layer, in which we can really connect in another way and find solutions, either in sensing or in response to change. But there's also this market layer which is happening. So this is important to know, because, for instance, the example of what I just showed you of the airport in Amsterdam, they can make money by the cars which are parked and are hybrid or EV. We did a study on that, and it's now implemented, that they can actually, when people are in a conference like you are here, they can make money with it, because there is an energy APX, which is actually an energy exchange in which the prices are varying. So you could actually build business models on it. And this is not something to forget, because, of course, all these changes which we just showed, it's really nice, but we need to find also business models to do so. And so these are actually the new, let's say, outlooks of the cities for the future. From my perspective, there's a lot more to say. I only had 20 slides. I think I showed more. But what I would like to show is this panarchy scheme. Because in the end, of course, the concept of panarchy in relation to resilience is very important. And I think what we aim to do with networked environments is actually trying to find this interscalar, which we are able to do now more easily by introduction of decentralized systems, but also by introduction of electricity and exchange by data feedback loops, so to call. So if I look at society, this is a very simple scheme I made just to make it a bit more clear where we are heading to in the urban areas and cities. And that's that we are actually introducing this in-between level. This is an in-between level between the local and, let's say, the national grids, or let's say the international grids. But this is what we call it's above community level, but where we can exchange. So the smart grids often are to the right of this scheme. And it can be an electricity-based, or it can be HVAC, hot and cold water system, or even organic material, as I showed you before in Culemborg. But also local food production. This in-between level is very interesting to know, because this is also a level in which you can really, let's say, connect to community building. This is where communities are organized. And so I have two quotes to end with. And they're actually, I think we are agreeing quite significantly on this. So they are actually that if you look at future cities, and of course of these opportunities I showed you from a perspective of IT and of market, but especially from needs to change from environmental perspective, it's really, really urgent, I would say. Well, we all know, I think, here in this room, but I'm at the moment actually writing a book on water. It's going to be released in fall, and it's really urgent, I can say, the water issues on the world. But if you could say, if we could really harness our information by sensing or by feedback loops by users to illuminate the truths of urban life, it's very important that this continuous physical interaction of human beings in urban space, that they also should be included. That it should be based on urban communities and the natural systems that support those communities. I think if we can find a way to do so, then we really can build a more sustainable future and resilient, I would say. So, but I would really like to be an open discussion now.
Yeah, yeah. We will do it. Unfortunately, it seems that Hervé Le Treut didn't succeed to reach the room. He should be on his way. And maybe you have some comment?
Yeah.
Yeah. Two of you, yeah.
Yeah, very short and also raising questions, so that maybe that this can solicit the discussion a bit more. So my comment regards, I'm from the Natural Hazard Division here, so, and I'm expert in tsunami, so I would comment what you said about the effect of the impact of the tsunami and the response of the Japanese people, and to convey maybe a better idea of what really happened there and why they had 20,000 or more fatalities. So partly is certainly true what you said, but the main factor that caused that, this is with the discussion of the Japanese people, is that there was at the beginning a very strong under-evaluation by the Japanese tsunami early warning system of what happened. And so they under-evaluate immediately the magnitude of the earthquake, and so consequently they under-evaluated the tsunami height. Better to call it tsunami than tidal wave, because it's a tsunami. And they under-evaluated the tsunami height, and so they released immediately an alert expecting at most a 3-meter tsunami height at the coast. So why people did not evacuate? They did not evacuate because they had a protecting system very strong, and most of the town were protected by seawalls as high as 6 meters. So they felt safe. So they didn't evacuate. They started to evacuate half an hour later when, for some reason, I don't go into details, the tsunami early warning, the alert was raised to 10 meters. And so they started to evacuate, and they evacuated, and they have a splendid evacuation map and routes, but some of them evacuated instead of horizontally, so to higher altitude, they evacuated vertically. Vertically means they had special buildings, and so they went in these buildings and on the top of these buildings. But in many towns, everything, because the wave was more than 20 meters, they, of course, overtopped the barriers, the seawalls, and even the highest buildings that they have were overtopped. And so all the people that were, they tried to escape there were killed. So this is the real. And there is a video that I saw, but it's not so public, so it's not in the web, where they are taken from another building that was still there, but of people that evacuated on the top of the building. And okay, it was impressive because the wave increases, raises, and of course it's dramatic for those people seeing that they are close to be killed, and so they, at the end, the building was totally submerged by the wave, and so they were transported and carried, and they were killed. So this is the comment. The question concerning the urbanization. So I'm sure that some 50 years ago or so, after the Second World War, so the world had a new life, in a sense. They were asking what we are doing, certainly a more peaceful world, and that was the main concern, the peace. Probably we are not at the same level, but they were asking also how can we construct better towns and better cities. But at that time, I mean, why? The question is, why the model of urbanization now, after 60, 70 years, is such that the big mega cities that were there and that 10 million people and now have 20 million or 30 million people. So the question that I want to ask you regarding resilience on, against natural hazard, are 30 million people density in a specific town better protected than in a different model of where there are several towns around? So this is the question for resilience. So a big town as Tokyo, 36 million people now, or Los Angeles, 23 million people, or others, are better protected against earthquakes or against any other natural hazard than smaller town? So this is my question.
Thank you. Cedo, you want to say some word, but very short, because I believe...
Okay. I'm Cedo Maximovic. I'm professor at Imperial College London. Concerning both speakers, it is evident that key problems are lack of coordination between the different specialists. People work in silos, they don't communicate. People work from one extreme to the other. Let's put more green, more trees everywhere. It's not the solution. And then let's cut the trees. We need trees, but we need select them by their characteristics, by taking into account the wind directions, by taking into account all the integrated modeling. And that is lack of this integrated approach in which we combine both technical disciplines. We bring all these people, ask them to forget their ego trips behind the door and sit together and then plan for the future cities. That is the way to go. Otherwise, we will continue having less and less resilient cities despite all these modern technologies and big data and so on, including social aspects. Social aspects very important, I fully agree, and these people also have to be agreed from the very start.
Okay, thank you. Now we have to start the general discussion, so don't waste time. Okay.
Okay, I'm happy to ask the first question. It's in reaction to both speakers, but in particular the comment Sebastian made about the challenge and opportunities with the cross-cutting activities in a city and how you need to make more efficient and consolidate and get added value across those activities. And in one way that we see it is through the World Meteorological Organization and the United Nations Environment Program initiative that's got started a couple years ago on greenhouse gas information. And one of the foci is urban. One of the four big objectives is in the urban frame. And what we see is that there are many city managers and mayors who are part of the 100 Resilient Cities and others that have already embraced activities to reduce their greenhouse gas emissions, but many more have been focused on air quality issues, and they have big investments in the network of observations and information collection activities focused on air quality. And there's a very strong cross-term there between those two kinds of activities. One's focused on reducing emissions of greenhouse gases that can at the same time improve air quality if they were designed together. And I was wondering if both speakers could comment a little bit on that. We see that as a challenge in terms of connecting with mayors who are, or city managers who are tasked with managing the air sheds and their emphasis, their priorities, and how we can get them synced up between both air quality and greenhouse gases.
Okay, thank you. It's maybe better to collect a few questions. Yeah.
Joel Drill, British Geological Survey. Could I invite the panel to comment on the importance of achieving the 5th Sustainable Development Goal, gender equality, if we're to deliver resilient and sustainable cities?
Okay, we go on. Okay, yeah, please.
How do we deal with the problem of the spatial distribution of people within cities and the focusing of jobs and business in the centre with associated problems of rent increases and long commutes and that kind of thing?
Thank you. It's another comment. Okay, there is nobody else? Okay, so who wants to start?
At first, about the first comment, I can just show you the references about the tsunami saying, just for you to note maybe the references of this study, because it's quite interesting. I totally agree that I knew about this under-evaluation, but it was the same for all the villages. And once they discovered it was under-evaluated, they reacted differently. And this study shows that the people who were saved are the elderly and disabled people. Why? Because the social cohesion within the cities created this, the fact that people knew that at the second floor there was a disabled people, and then in the other house there was an elderly one, and so they had the reflex to help them. In the other cities, neighbors didn't know each other, and so they didn't even know that there was an elderly people, an elderly or a disabled. So this is quite interesting to see how we can modelize as well. I don't know, I think we are still at the beginning in the human sciences, how to modelize the effect of social cohesion and what indicators can we build in order to measure social cohesion. That's a huge concern for us in Paris, and we still don't have the solutions. The link between air pollution and mitigating global warming and carbon emission. It's a huge concern, but I totally agree. So far, even in Paris, before the resilience approach, it was worked separately. And that's a pity. That's a pity because, of course, we could be more efficient working on both issues. And what we've been doing to work on this is to ask to researchers to help us. Because even if the holistic approach is not totally completed within the academia domain, multidisciplinary work is a practice, much more than it's supposed to be. And so we're expecting the research and the science to provide us actually more than the startups. Of course, the startups as well. But there are so many magic solutions so far that try to, we have these sensors that are supposed to measure everything in the same time. Why not? But there are so different proposals of sensors that we don't know which are relevant or not. And so we need the cities need the research to work on this. And maybe I'll let you answer to the other one.
Well, I can just shortly continue on this last point about particle matter or about air pollution. I think it is quite complex indeed. And what we are finding, well, in our institute, which is MIT, Delft and Wageningen combined research, we actually are now starting with the 3D GIS-based city models combined with the sensing throughout the city, which even makes it more complex because the city is quite, let's say, non-dynamic, while the air pollution is quite dynamic as a feature, and also three-dimensional. So we are finding out a lot now related, and I think this is the first step, of course, that we really visualize almost what are the effects on the what extreme, on what conditions, let's say, in general conditions. But with sensing, you don't have solutions. So that's another issue. So it's only a first step is illuminating what's happening, and then we can act on it. And I think one of the things we are now addressing with studies from Wageningen University is actually the urban roughness. So you could change urban roughness. And this also links a bit to the density question, the third question, I think, or the second, which was about how should we combine people, or should we densify cities or not? Should we? It really is depending on the perspective again, because from energy perspective, it's really wise to really densify up to a certain extent. But from air pollution related policies indeed or strategies, it's much more interesting to make a more urban robust, and that's what we are investigating now. How to make, let's say, a model which defines with all the possible, let's say, variables for architects or urban planners to still make their dream-like environments, to really also have like a feedback loop through modeling of their urban robustness. Because that's the way which relates to wind again, in a way that it can help. And then, of course, you should still also address ways to get rid of its origin. And that might be through electrical vehicles and by many other, let's say, transitions. But it's a long story. Yeah.
Okay, so Hervé Le Treut succeeded to arrive. We are giving him a few minutes to be ready to speak. And if there is one question, we can take it now. And after that, we will give the floor to Hervé. Okay, in that case, I will make a short summary to Hervé because, in fact, due to your absence, due to Air France problem, the discussion was mainly from the cities, not so much about geophysics because the expert was not arrived, simply due to that. So now we have maybe to discuss more the question of geophysics and cities, and in particular, there is a question whether IPCC and COP21 took into account this problem enough, or are we just at the beginning of that? And what kind of experiments do you have in mind about that? Okay. Okay, so you're ready?
Yes, more and more.
Okay.
Okay, so this is probably, yes, this is working. I'll try, I'm sorry, really there was a problem with, we were in the plane and people were changing the wheels and we had to wait for quite a long time. And otherwise I might have stayed, maybe. So I'm really a global climate modeler, but I've been active recently in two kinds of expertise that was not exactly along my issues, and I've put that. I'm in fact head of the Institut Pierre Simon Laplace, which is a big federation of laboratories, but all I would say group one of IPCC. And but I was involved in two things. First, the pilot committee of COP21, and within this pilot committee was mostly tried to gather a small group working with INDCs and what the proposals of the different states. And the other thing is I'm from southwest of France, from Bordeaux, and I was involved, I was in fact, I took the initiative of setting up some RPCC, not IPCC, but Regional Panel on Climate Change. And so I think this inspired me a number of reflections which I try to put in this, and I will not have time to do it in details, but maybe I'll just try to browse and go through the main issues I wanted to raise. I think the first thing is people, and I've realized that, don't realize exactly the kind of pressure that what have been signed at the conference in Paris will put on any development, and especially the developments of the cities. And this is the kind of trajectory we have to follow in terms of CO2 emissions if we want to stay under 2 degrees with a 60% chance. More or less, this is our model, so it's not statistics, but it's more or less what it shows. There is some idea that we could do with with some emissions. We have already put too much into the atmosphere, so we have no real capacity to put more after. Well, we should. In 20 years, there will no way from current models to stay under 2 degrees if we go on the way we do. It means no car. And part of the time I've wasted was from the airport. I had a bad idea to take a taxi. And which is, I think it's really a huge transition. And in terms of pressure it will put on the development of all industries, all cities, of all organizations. It's something very strong, and I think it's really underestimated in the kind of approach we have. We try to think we can do it in a smooth way, but if it's not really what has been signed. So I'd like just to emphasize that. I won't go much more on this, the different slides. Maybe one thing is that when you look at the different pathways that are being put in terms of reductions by IPCC, and you try to superimpose what the different states have proposed, it's very far from being enough. So proposition that will be examined in 1.5 years from now in the COP, not next COP, the one afterwards in 2018, will have to do with proposals from the states which are not sufficient to stay under the 2 degrees. So it means there will be, if we don't do something extremely rapid, something which there will be some warming. So I see there are two dangers, and that's what really is the essence of what I wanted to say. One is that those transitions, if they do happen, will be extremely strong. I mean, if you want really to have a world where 85% of the current energy needs, which are presently covered by the use of fossil fuels, will be replaced by something else, well, that will create jobs, that's sure, but that will destroy many of them also. It's a huge transition, huge transition. You cannot do that without the people. We are living some elections in France right now. There are things you cannot do without the people and without the society. It's really a very huge transition. And the second thing is that there are some risks that this doesn't completely happen. And then you have to deal very seriously with adaptation. And one of the reasons is that all the problem of climate change is mostly some unfair problem. It's unfair at the level of the states. It's also unfair at the level of the people in a given country. I think people do realize it very, very well when they hear about transition. Say, okay, transition that will be for the fair people, not for the poor ones, and that will help some classes of society, not the other ones. So I think this is something which we will have to take into account, these difficulties, which comes from the big picture, in fact, of the problem. And I don't think there is enough attention. At least I've noticed in France that many laws, for example, are taken without thinking too much about this problem of how they affect different classes of people in the society. So there is really something really very important. The other thing I wanted to say is that there is also something which must last for a very long term. So we are not going to, it's something that has to last a very long term. So it means that we have to start now structural things. We cannot, if we really want to erase all these CO2 emissions or a good proportion of it, well, we cannot wait until difficult things are there. We have to start them now. Everything which is structural has to begin now. It cannot be left for the last. So this is also something I wanted to say. We have to start structural actions quickly. And this is also, as this is transportation, as this is housing, this is mainly in the cities that we have to start this. Mainly the cities. Okay. Now, the last thing I wanted to say, I will stop there, is that I think the region are a very important place because probably that's a place where we have some space for democratic debate. And because when we have to deal with the choices, well, they are very concrete. We are at the scale of the Earth, have to take measures concerning attenuation, adaptation, and other kind of measures. We have to deal with social issues, with biodiversity, other environmental problems. This is a bit theoretical, and in fact, comparing all those risks is not something that is easily done right now. At the scale of a territory, not only it is done, but it can be done with some debate. And adaptation also is something which gives us a bit more time. So we have the time to debate on how we make the choice. And I think this is especially important because I repeat myself, I think the problem of educating people will be a key issue. I think things won't happen if there is not a strong way to let people appropriate themselves, which means that the scientific community should listen to the people. And that's why we did this RPCC. So I was surprised, I skipped those things, to realize that was the western part of France, Aquitaine, tried to look at many different things in terms of, and we had more than 100 head of groups, head of laboratories that were concerned by that. So there is a lot of information we don't look at very much, which can tell us about what will happen, and we should use that for the public debates. Briefly, what I wanted to say in more detail, but yeah, that will be.
Okay, thank you, Hervé. Are there questions about what Hervé presented? If not, I have two questions at least. Okay, maybe you can switch my computer, by the way. There was a series of questions at the end, that third theme, sorry. And I think that we discussed a lot of different questions, but nevertheless, we spoke very quickly about IPCC on COP21. But for example, for COP21, we had the surprise to have only one institutional conference about water. Only one during the COP21. Of course, it was water in cities by chance. So there's something we are not very good about that. We spoke a lot about integrated responses and so on, so I believe that's working. There was example of experimentation and living labs, but at the same time, we didn't try to focus so much about the scientific and technical deadlocks, because there are. I think it's important that people are mobilized for this question, as you said it, but at the same time, we are facing difficult scientific problem, and where we should put some emphasis in order to overcome the difficulties. And the last thing, I think it's more about to the floor, is the question, what synergies EGU should generate? That's a big question, because we spoke our time to speak that it's bad to think about silos. But unfortunately, EGU is working with silos. Stefano spoke about his former division in Edge. I could have spoken about NP. And we have been working for a while indifferently with not too much exchanges. But when we are facing such a problem, something should be done. Not only in the city of Paris or Rotterdam or Amsterdam, but maybe at EGU.
Okay, yeah. I think, yes, there is a responsibility of science that really is something we should think a bit more. If I take it from my usual view of the things, I agree completely that COP21 is something nice in the sense that it says really, and it has been approved, it says what are really the goals and the necessities and the kind of problems we are facing. At the same time, it's not something we are in an easy way to face, because of all the diagnostics are made as if the world was non-conflictual. And what will happen in the next rounds of the different COPs will be to try to determine what are the countries that do well, that don't do well. Will science try to say something about this? To try to measure what is being done, to try to monitor what is being done. I think that's a word I didn't repeat, but monitoring the thing, telling, and monitoring it also country by country. All the IPCC, for example, will never try to get into some kind of opposition between countries. These one are good, these others are not. This is something that someone else has to do, and if scientists don't do it, I'm sure that in 2018, very little will come out of the COP where the proposals of the state will be reviewed. They will be reviewed against what? Against what kind of science? What kind of... So I think we are really missing something, because things are evolving very quickly. Science don't change track quickly. It's nature. And we have responsibilities there, I think.
Yes, there is a
in charge
question
of the Twitter
on
account
Twitter
have something to
from
tell us.
the audience. So, what about developing countries and peri-urban areas?
Well, yeah. I always refer to Lefebvre, of course, who says that we have the right to the city or the right to infrastructure, and I think this is really happening in the world. That we are talking about smart cities or our cities in, let's say, in the global north or here in the west. So yeah, this is what also was stated before. They are the ones who will suffer or are already suffering most the extreme effects at the moment. So this is really something to address. And this equity principle within sustainable development is often forgotten. It's mentioned, but it's not. And this is an eternal and very important, if not the most important one, because well, wars will be fought over water scarcity the coming time. And so between nations, there will be a lot of issues, and this will happen quite soon. Regarding peri-urban areas, well, actually, that's an interesting quote, because I just started in September a huge European project on peri-urban areas, because they happen to be, let's say, at the moment where both opportunities and problems meet in relation to circularity, waste, but also in relation to food, water, industrialization. Infrastructures are often in peri-urban areas, but also growth, the pressure of urbanization is in those areas. So we can make and break, let's say, our future there. So I think there's a lot of focus on urban areas, but I think we might need to shift towards peri-urban areas and indeed the whole metropolitan scope. This also, I would like to confirm that this regional perspective is a very important one. Actually, together with the community, which we discussed before, these are the only two scales, or these are the two scales which are not well represented by governmental, let's say, or by institutions, by law. And I think this is something which we need to. So if you talk about deadlocks or problems, I think one of the issues is that these are quite essential scales of both the community building on the neighborhood or district level, and the regional focus related to, let's say, strategies towards change and climate change. And
So I
yeah,
push
okay.
you out.
I will hand it off. Yeah.
Really quick, very fast. Urban resilience has to be understood as urbanity resilience. So it means it includes the countryside, the peri-urban areas, and so on. Especially because the city is nothing without the countryside. Paris has 4 days of food self-sufficiency, 4 hours in case of major crisis. A city is nothing. Even if we develop a lot of urban farming, we won't feed the population in this dense and with 30 million inhabitants, as you said before. So, of course, this integrated approach has definitely to include the countrysides and the peri-urban areas. I have a deadlock, a practitioner deadlock that might interest the scientists. And in the modelization of the result of our efforts to mitigate global warming, is there any reflection now about the critical time in the future when adaptation will be more important than mitigation, especially because of political and citizen pressures? So far, cities are committed in mitigation and spend more and more money in our investments to mitigate. Because so far we don't face that many heat waves, and we still don't have water scarcity, we don't have food scarcity, and it's something still far. But once the French heat wave we faced in 2003 will be just the common summer and last 4 months, once we'll face water tensions, the pressure on the mayors, on the elected official, will be very strong in order to find solution now to refresh the city using aircon, getting water coming by truck from the other side of the country. And so is this integrated in the reflection, in these pathways that we see now, the critical time when we won't have when we'll have in the cities 1 million to spend, the pressure will be so strong that we'll spend it on adaptation and not anymore in mitigation, and then the vicious circle will continue.
Just one thing, I think I partly answered that. In fact, that we are already almost in a situation where it will be impossible to stay under 2 degrees, except if we take out CO2 from the atmosphere, which is something should be part maybe of other debates, but so far it's not being done. So. I think it's already happening. I think there are changes, and those changes, if we try to look at what may happen, what models say for the next 20 to 30 years, there are big changes there, and it will be very difficult to impede them. So I think adaptation is a necessity, and it's more a necessity in regions which are already rather vulnerable. And so there is also some kind of unfair distribution of what are the regions where this is a necessity. Quite unfair, in fact. Yeah.
Okay, thank you. I'm afraid that we have to close the debate. Yeah, okay. Anyway, it's not exactly closed because you can use the Twitter account to send questions because it was an event, but we will not stop on this topic, especially with respect to EGU. By the way, this great debate was possible with the support of the past president of EGU, Hans Thibault. When I discussed with him, he understood what was many issues which are related to that, because for the present time, the question of cities are discussed in different sessions, which are very scattered, and therefore there is a lack of synergies due to that. And the question is what to do in order to be more efficient about this question. So please don't refrain to send suggestions by Twitter. And of course, we have to thank the panelists for their contribution. And at the same time, the attendance was very patient and numerous. Okay, so thank you very much.